Thank you, Enzo. Today, I'm going to talk to you about full reactive apps with asynchronous flow and stateflow to sync with the UI. My name, as you know, is Raúl Hernández López, for who don't know me. I work at Twitter as a software engineer for the search team at the moment. Later on, you will be able to see the slides if you want to, if you follow me on Twitter. And also, you want to see the code snippets that you will see here. Those are in my guests under my GitHub username. That's Raúl H82 BLC. But let's go to the agenda. First of all, I'll introduce a use case why everything will make sense and why I did some choices about that. Then I'll introduce a migration strategy for going step by step without getting crazy and then becoming this legacy app I will explain in this case to be something more modern. I will introduce later on basics very quickly because I think basics are super important to master things and also to better understand what we are trying to achieve. And then the longest section of this talk, which is implementation. That's going to be a bit intense, but bear with me. And then in the end, I'll explain you a few lessons I learned along the way and next steps that I think are interesting. Let's see the use case. About the use case, you can see that I was starting to type into a search mechanism. This is, by the way, a sample app that I created in my spare time. And you can see that you have also a detail of those particular items, and this is basically the results that you get when you are typing. So this is something not very complicated, but complicated enough to see a few use cases and what we can do to make this better. So we have here a few things like empty state, like if we have any errors, and also typing and then synchronizing everything from the moment we are typing. So we need actually a reactive mechanism. For that, let me go into the migration strategy that I think is relevant and interesting to explain. First of all, this application was built about 3 years ago, so that means it's very legacy. And if we want to migrate something, then we do need to do a big refactor. And for that, we'll need to follow some steps, step by step, just to make sure that we are not breaking things along the way. For that, in my opinion, analyzing previous architecture is critical for that. And by that, I mean, I had at the time something in the data layer with a repo and then some data sources, everything built on from the ground in Java. So you can see the repo is controlling different data sources, network, and DB, that means offline mechanism. This was connected with the business layer. That means for me, a use case or an interactor. The use case is requesting things to the repository and doesn't really care about where is this coming from, but it needs the results at some point. And then this, which is connecting the clean architecture with the presentation layer, is connecting that with the model view presenter I have at the time. This presenter is also built with Java, as you can see. So the presenter is executing this use case, and this use case is requesting this information to the repo, then getting those results back, and then this going to the view. Actually, everything started from the view because the user types, as you already know from the use case, and then those views are interacting with a view delegate, which is gonna decompose different functionalities in order to provide a passive thing to the view. So basically the view gonna be passive. Everything that is functionality-wise from the view gonna be done into the view delegate. And this view delegate will start this process, this reactive process from the presenter to the use case and to the repo, getting some results back, and then those coming with callbacks from the use case. As you can see, this is pretty legacy, but we'll see my proposal. So then we need to check the backwards compatibility requirements we had at the time, and then going step by step. So at the time, I had RxJava. Basically, we need to make this coexist by time being because we're going to migrate this step by step. And then we need to actually analyze the different endpoints because we need to come from one place to one another without breaking everything. That means if we have some inputs, we are expecting to have those outputs to be respected because then we can migrate something and then go into the next step. And for that, we can see that we have RxJava all along the clean architecture side, that's from the use case to the data sources. And also for hot observables, I have this from the view delegate, which is starting and triggering this mechanism from the Basanta. Then if I want to migrate that, I will start, in my case, and in my opinion, you can change and do that from another place, obviously, from the database data source. So I will migrate that with Kotlin. I will introduce some RxJava, some coroutines, probably suspend functions. Then I will go to the repository, then using Kotlin plus RxJava again, because remember, if we are migrating things, we need to return those singles or observables because those are the ones expected from the previous layer that is communicating with you. And then the same, once this is migrated, we can change stuff, and probably we don't need to have observables there in the data sources, and we can just rely in, let's say, flows. When this is migrated, we have those flows here. We can make sure that this use case is also validating that. And here is basically the case for the clean architecture side. But now we are going to the view delegate, which is also having some hot observables. That means for me subjects. And this can be changed using channels as flows. We'll see later. But then if we want to get rid of those callbacks that probably are not the best choice, probably we can do a bit more. For that, I will suggest to use Stateflow. Why Stateflow? Because Stateflow gives us the opportunity to use things across different hybrid files. That means Java and Kotlin files. So if we have this migrated from the whole use case and also the view delegate with Kotlin already, but we have a very strong and big layer in the views that cannot be migrated just yet to Kotlin, then this can be used actually. But then if we are using Stateflow and we need to collect the results from Java, then we're going to need something else. We're going to need a collaborator. In this case, I called it a Stateflow handler. You can call it as you prefer, obviously. And this is the one responsible for processing those results and then initializing things for the view as a helper. So that's basically my approach. A few benefits I find about using this approach is, for instance, reusing existing elements. That also means architecture, because we don't need to change the architecture to reuse existing elements. The only thing we need to take care of is to have separation of concerns, because then we can actually change the things and making sure that with a black box kind of mechanism for certain inputs, we can have certain outputs, and those are going to be expected, and we can change also the tests along the way. Also, because we do use this kind of collaboration between layers, we can make sure that we are not having breaking changes, and if you work in future modules, you won't affect any other colleagues at work. But let's see now some basics that for me are really important to better understand calling coroutines in general. Let's start with what is an open stream. For me, an open stream is something like that. I say, hey, in Vulkan right now, and somebody in the other side, Christina, is right now practicing some maths, teaching some maths, whatever. But the thing is, I send the message, these greetings, but she answered me that. If we close right now this, that means that this is going to be a closed stream. It's one short request. But if we keep going and we have this conversation open because we are emitting more values, that means in a stream or in a messaging app or in real life, per se, then we have an open stream. That's the case. And for me, it's very easy to understand that by having this example. But obviously, we don't need this for every case, right? We are not going to use always open streams. For instance, for network requests, because we're going to do some requests and maybe we don't need one another after maybe half an hour or more. So it's just one sort of request. And for that, what do we need? If we think in coroutines, we could use, for RxJava, for instance, we used single that uses a not nullable value, and the correspondence to that is a suspend function returning an object. But if we need something that is nullable, then we'll use maybe in RxJava. Comparing that, in coroutines, we use a suspend function with a nullable value here in suspend. Then finally, for one single operations, then we have completable, which is the fact that we don't return any value, but we have a completable action in RxJava or a suspend function with a unit because we don't have any returning type. As simple as that. Then for threading, we're going to have schedulers in RxJava. So let's compare that. And we'll have also dispatchers for coroutines. They're going to be used for suspend functions, flow, stateflow, and so on. We'll see later different types. Then the life cycle, that probably is one of the most important things, in my opinion, about both things, coroutines and RxJava. For RxJava, we'll use disposables that can be disposed, that means finished, by disposables in this case. And then we have scopes for coroutines. And the scopes are even more powerful than disposables because they have superpowers. They have something called structural concurrency. This is very cool because structural concurrency gives us a few advantages that we didn't have with disposables. For instance, if we cancel this scope, we can have recursive cleanup. And by this, I mean something like this example over here. The scope is being canceled. That means that we have a few processes below this scope, process 1, 2, and 3. But the fact is that we're going to cancel all of them if we cancel this scope. It's going to be automatically done by structural concurrency. If we want to do something similar in RxJava, we need to dispose all of them manually or using composite disposable to attach all of them to one composite disposable. But if we have different layers, then we need to do for every layer in RxJava. So that's slightly different. So by that, we can have recursive cleanup, and that means avoiding memory leaks for free. So that's very cool with the structural concurrency. Also, if we want to see something different and we want to make and avoid some side effects on cancellation, let's see this with a scope, which is basically the default, plus a supervisor job, which is a different type than job. Then we have something different like this. We can avoid other children cancellation. By that, I mean, we have this scope plus supervisor job, and then we have those three processes that we mentioned earlier. And this process 1 just got canceled because it thrown an exception. That means that probably we don't want to cancel 2 and 3. By having scope plus supervisor job, we can avoid that. And we have this in the root scope, having the supervisor job plus scope, we can avoid that. So that's very useful. Now let's see some implementation details and we'll dig into further things. For instance, first of all, what are the dependencies? I used in my latest version 1.4.0. I know that we have right now 1.4.20, if I remember correctly. But just for the sake of having things stable, I used that and I kept it. So we'll use that for both the Kotlin style library and also the coroutines version. And let's see this first step of the migration, data sources design with the network and the database. So we'll start here. We want to change all singles to return suspend functions, and then we'll return as the type a single for them. So let's see what is going on inside this network data source implementation. What I have inside is a Twitter API, which is basically a retrofit client with a HTTP, and then something for checking connection if we need it, and something to transform the requests and responses. Nothing else. This is a singleton because we want to reuse it in the whole app, so that's all. And then if we do have this method, what is a search, we'll have the token because it's an authenticated query for Twitter in this case, and then the query that the user is typing every time. So we'll search that with the token and the query. And in RxJava, we'll use the filter to check that everything is correct. So we go on, then we map those things to become those tweets from the DB. And then we'll, sorry, no, not from the DB. This is the data source network. We'll map those and we return those as a single because we are changing the maybe to a single right here. Then if we are changing this into coroutines and we need a suspend function. So for this particular case, I use either. Either has a few advantages. I will just mention a couple of them. There are many. This is actually very similar to Kotlin results. So it's something similar in that way. So we'll use that with the search query for the Twitter API. We'll return a response. We'll check that it's successful. Then we'll go on. And then we'll get the tweets from the network, and if everything is all right, we return this with either right in the tweets embedded there. But if something is wrong, the left side will be embedding this with the wrong response, something very similar to result in Kotlin. Now, if we want to return this as a single, then we have something very handy. That library called Kotlin coroutines Rx2, because by using this block operator with Rx single, we can return this as a single. So this is very useful because then we don't have to migrate right now the repository. So we can just do it for another day. And then for the library, I use room. You can use anything else. And I return also a single type. As you can see here, my query is just selecting everything that is in my table of tweets, by returning those things coming from the IDs that I am passing in, and then ordering by descendant order, nothing else. Let's go to the repository design and the step 1 to learning a little bit. And also I'll mention that this is my naive approach because I made some mistakes and I learned from them. And that's why I came to this kind of first approach, which is my RxJava approach, because I came from the RxJava world. And let's see, repository call using Kotlin plus Flow and RxJava. So we'll return here an observable from the repo. So the repo is basically having the network data source interface. That's the one we mentioned earlier, and the different tables we had in the DB. That's the tweets database, token, the query, and the combination of the query plus the tweets, this kind of intersection table. Then the different mappers to transform things from the network to the database, and then finally something called task threading that we'll see in detail later on. Now, the method that I use is get search tweets with the token and the query, returning an observable with a list of tweets. So we'll use the network data source into the repo by searching the query, passing the token to authenticate this request to the network. And then we'll subscribe to the IO because this is an input-output operation. And we'll observe in computation if we need to do any operations later on in the computation thread pool. We'll map those results with the mapper, getting those results back from the either operator from the arrow library. And then we'll do a next with the tweets we want to add to the database. We'll do a kind of updating mechanism by deleting first tweets, then inserting the new ones, then inserting the query, and then inserting those IDs from the tweets IDs to this combination table. You can do actually an update, but I decided to use this strategy for deleting and inserting. Then I did a flat map to combine this in a sequential way. So I retrieve those things from my query that is already in the database. And finally, with those tweet IDs and the query that you checked a moment ago, I'm going to return those tweets, a list of tweets in the observable that we have in the return type. If we want to do the same with flow, my first approach was returning a flow right here, and then using exactly the same operators, a map over here on each instead of doing next with those things I mentioned a moment ago, and then flat map concat instead of flat map. Nothing different than the thing that I had before. So it felt really, really cool because it was super similar. Nothing else to change. Just the return type gonna be a flow. And also for the database, I'll do the same. I'll return a flow because room is prepared for that. But then we need to do something for subscribe on, but in this case for flow. We'll use the flow on operator. The difference that we have from the subscribe on and flow on is the fact that flow on works upstream. So if you want to use it in the previous things, you need to put it down, all of them. Then those want to be affected by the IO dispatchers we have there. And then the task trading, that is the thing I mentioned I'm going to explain into detail. I use here different schedulers, so for the computation one, for the input output, and for the main thread of Android. So I expose those methods into those, those instances into those methods, and then those ones can be mocked for different tests. But then if we need to use these for coroutines, we need to use dispatchers, coroutine dispatchers in this case. So I created a few series of methods to have exactly the same equivalent. And then what do we want to do if we want to reuse them? Actually, if we don't want to have 6 resources in memory, but only 3, this is absolutely possible. If we want to do that, we can just use, again, the same library and using the asynchronous dispatcher operator that we have into this library. This is going to convert this into the coroutine dispatcher, which is super cool. And we return this in a coroutine dispatcher way, just using those 3 same things that we had earlier. Now, by using that, we can return the observable because it's the thing we are expecting to have in the use case. Then, if we want to go to have a step forward and then going a bit more pro, just leaving that and having the native way to use coroutines, then probably we need a suspend kind of approach. So we have migrated everything already until here, and we don't expect to change this repository with those things. So let's see. So changing that, if we only want one shot operation, this is enough to just return suspend. So to have this close, suspend, and then returning list with tweets. That means we don't need anything else but the list of tweets because the suspend function is going to be responsible to do that. And then we'll do a coroutines way by having imperative code right here. So we'll do those things that we did earlier. We'll return this from the search network data source, and we'll map those. We'll do the same operations than earlier. We don't need to tell them anymore. And then I try to experiment with something else. As you can see here, I try to return a flow into a spam function, but is that even possible? Absolutely not. This is not possible because we have a one-shot operation. That means we need to return as a spam function. And we can do something like that. We can return as a spam function if we need it inside another suspend function. So if we need to do that, we need to change also the database, and we return as a spam function over here. Then the tweet repository returning a flow. So for instance, we can do something like that. If we want to do, let's say, the use case of a poll with a database being refreshed by the network every 30 seconds per se, that means if we want to have this from another entry point, and we want to change and refresh the values from the UI, by emitting all values right here, we can make sure that this is refreshed every time because it's an open stream that we mentioned earlier. And also using the flow builder. The flow builder is super handy because it's gonna allow us to use emit all in this case, and a few more that we're gonna see in a moment. For instance, this, if we want to return just one value, we can do emit and returning the suspend function that we had earlier, the retrieve all tweets from tweets IDs. But this is one-shot operation, so this is not the best use case to use that because it's one only emission. For that, we can just replace the return type to a list of tweets and adding this span modifier to the get search tweets. But let's see another interesting case. For instance, here, if we want to use the flow builder, we can emit different values more than once. Let's say we want to show first the dirty values of the database. So we're going to emit the values from those retrieve all tweets from tweets IDs. And then we can, as soon as we have this refreshed, emit the new values that are fresh from the network. So we could have this kind of offline mechanism. Of course, using flow on upstream and using the IO dispatcher because it's an input-output operation. And we'll need to use an observable right there. So we'll use as observable to change the type. Again, using calling routines Rx2. Now let's see what we have in the use case design. For the use case, I am planning to have everything else change so far. So here I am expecting that I'm going to return a flow, and then the use case is going to be responsible to handle that. But let's see what's the difference between the previous approach and the new one. For instance, search tweets use case with the constructor, I have inside here the repository, and again, the task threading. This search tweet use case that is in a routine scope just for changes, configuration changes, is going to use this use case interface with a callback right here. So this interface, this contract, is basically having a parameter that is the callback And then the first parameter in the execute is the query, and the second is the generic type, that is the callback I am expecting to pass right then. And then the cancellation method, that's for disposing in RxJava world. Then for RxJava, the difference is RxJava plus Java. So I am executing this from the use case. I pass the query, I have the callback is initialized. I check that the callback is not null, and then if it's not null, then I pass the callback, and I show this dialog that I have at the very beginning when typing the query. That's the loading state, and then the callback do the on-show loader. So we'll see this kind of dialog pop up that we show it to the user when it's loading the results. Then we'll do the search tweet query in the repository. We'll subscribe, so we'll pass actions that are successful into this very first step of subscribe. That's using the callback with on success. If you have any problem, then we'll use on error on that for the error handling. Then we'll basically subscribe to the computation, because we're going to do some computations maybe. And we'll introduce this map for doing those computations if we want to. But we'll observe this in the UI. So that's why we'll use the taskthreading.ui. Then we'll return the type for the lifecycle to this disposable, and this disposable is going to be cancelled or disposed later on. But if we want to do the same with Kotlin, I change that. So the execute method when I have the same parameters, callback right there, Kotlin as you can expect. And then going to use for coroutines a scope. This scope going to be used with a launch method because we need sequential operations right here. I won't explain anything related to parallel because this is out of the scope of this talk, but let's focus into this sequential approach. So as you can remember from the previous introduction, I use supervisor job because I am avoiding side effects. That's why I use that from the coroutine scope. This can be here, it can be injected into my use case, and then I'm gonna launch that. I'll make sure that the search tweet is making this, so I'm gonna map that, exactly the same, and then flow on gonna be there because remember this is upstream and needs to be down the map, up, basically below that, and this is gonna be in the computation dispatcher thread pool. Then, if we need to catch any errors, I'll also add this catch operator right after flow on, because we need to catch those things, and those things need to be in the UI if it's a callback. If we need to do anything else, that's another thing we need to do in the other layers. But for this case, the callback gonna pass to the UI, the on error thing with the different states of the problem, and then we're gonna collect the results, the right results from here. So we'll get the tweets. I'm gonna pass the tweets with the callback on success right there. Also, this can be done in this another way. If we don't want to have this verbose scope.launch, we can use launch in that by default does it for us. And actually on each, we're gonna replace this collect. So it's a same functionality, catch over there, that's gonna be all. Then, if we need to cancel this for making use of short concurrency, we'll use the cancel method, and then we'll cancel the scope to start concurrency. Obviously, we'll nullify the callback to avoid memory leaks. And then, if we need to do the same in RxJava in the old times, we need to do something like that, making sure that it is there, that it's not disposed, and dispose it, and making that null. Something very similar, not a big change. Now that we changed this, all the clean architecture side, we can just remove the as observable from that library I mentioned earlier and just return as a type the flow. Let's see what we have in the view delegate design. So the view delegate design, if you remember, is basically the helper of the view. That makes the view totally passive because I don't want to get any responsibilities in my view. And it's gonna have the view listener for the search view that we'll see in a moment from the Android native component. And we'll start this reactive mechanism by the hot observable. And then we'll replace this from RxJava to channels. So first of all, this is gonna be in an activity scope. We'll introduce as a dependency a presenter, the search tweet presenter, and I will create a publish subject. That is basically the one responsible of passing a string. That's the query. I'll prepare this with the search view. That's the native component of Android. That can be another text, of course. That's up to you, really. And then this views listener gonna pass the public subject as a parameter. This listener needs to be set up to the query text listener of the view. But then let's see what we have if we want to use channels over here. Basically the same parameter, we use the presenter, then we pass search view, we're gonna pass a flow when it's a call flow. But first of all, we'll use a channel flow for this particular case with a string. We'll define the listener inside into this block of channel flow, and we'll pass a channel inside this search view listener instead of the public subject. Interestingly, you can see right here, please pay a little bit of attention, channel is not initialized anywhere. You cannot see this declared, you cannot see this initialized, because channel flow builder is making this instantiation of the object for us. So we have this channel for free from this block. That's very interesting. Also, we could use a await clause to make sure that anytime that the scope is canceled and we need to cancel everything with static concurrency, the view gonna nullify this text listener to avoid memory leaks from the view. That's very relevant. Then, if we need to do the same with disposables and RxJava, we need to pass the disposable, and when canceling that, we need to make sure that we are nullifying the view into here. We need to do it manually here. And then disposing that, canceling the things from the presenter to avoid things from the clean architecture side. And the search view listener is basically having this public subject that we already mentioned from the RxJava world. And the listener, the search view onQuery text listener, has a couple of methods. I will only use the onQuery text change with the query. But what we need to have here to pass the whole observable is the public subject with onNext. Then it'll pass the query every time we need it. Obviously, you need something else like behavior subject. You can change public subject for that, or you can use something else. If we need to do the equivalent with channels, I suggest to use send channel because it's a synchronous operator. But the thing that it uses, offer in this case, send channel actually uses offer you want it. This will make sure that we are synchronous communicating that by making this synchronous with the UI. Then, with the view delegate and RxJava subject, when we are collecting the results, we'll pass this disposable, we'll use public subject, and we'll observe into the UI thread. Subscribing into the computation thread if we want to do any operations, and then we'll do the bonds. We need to have some delays for the queries. We'll make sure that we are not having the same query just to stop the triggering this mechanism if we don't have any different. And then the filtering of that, because maybe we don't want to start the query when we put a ASCII or an at, let's say. We'll subscribe, and then from that point, we'll start the search tweet from the presenter. And if we have any problems, we'll show us something from the presenter as well. If we want to do the same with channels, this is actually the flow that we have retrieved from the block that we saw earlier. This is exactly the same operators. So that's the bonds, that's distinct altitude change, that's filter, and that's flow on. That, remember, is upstream. So everything that is from filter to the top gonna be under the computation dispatcher. Then we'll use on each, we'll search the tweet from the query, we'll catch any problems there. And interestingly, if we use this catch until the on each, it also catches the problems from on each. If we use collect, the thing you need to do is actually embedding everything with a try catch. That's the main difference here. And when canceling that and canceling the scope, we're gonna cancel everything, starting the structure concurrency, and then making sure that everything needs to be cleaned up from the presenter and the architecture side. Cool, but are we done with RxJava so far? I have to say no. We have a little bit more work to do. For instance, we need to make sure that the tax trading is migrated totally. And by that, I mean, we used earlier the different schedulers, so probably we don't need them anymore if we have get rid of RxJava. We can remove those. We can just use the native ones instead, still 3 resources in memory only. And then I'll pass the different things to the default methods to be used anywhere. And now let's see the latest step of the migration, the synchronous communication design. By this, I mean getting rid of the callbacks. So you remember, we're going to start migrating the things and using the Stateflow, returning the results inside this Stateflow. So let's start. In the search tweet use case, I passed a repository and task threading. This doesn't change, but now we don't need to use the same use case interface contract because we're going to use something different. We're going to use the use case flow. And this is composed basically by the same methods, but change in execute, because we don't need anymore the callback. And also we need to expose the Stateflow. This Stateflow gonna be the return type, and this gonna embed a tweet UI state. We'll see later what is this about, but it's basically a seal class. And this gonna be nullable in this particular case. Stateflow, as I mentioned earlier, can be passed across different Java and Kotlin files, so that's gonna be very useful for this particular kind of hybrid project. And then for the use case, I will instantiate into this use case my Stateflow. So we need to instantiate a mutable Stateflow. And we'll make sure that we are doing that with the tweet UI state that is nullable. I want to mention that this is nullable for the sake of doing this quickly, but the right thing to do is having this non-nullable and then making sure that we are covering all different states. For instance, the idle state with nothing when nothing happens. Then I will expose it with get Stateflow, and I'll pass this tweet UI state to whoever stakeholder needs it. Then good thing about Stateflow is that by default uses distinct alt-int change, and that means that if you try to do this alt-int change to the Stateflow, it won't have any effect. Actually, it's one of the crossed methods you go to the documentation because it's already there. It doesn't have any extra functionality, cannot be done. So tweets UI state is basically the composition from this seal class, this contract, with the different safe types we need, and the data class with list results UI state, embedding the tweets. That's the successful tweets results that we got. Then our UI state with the message that we need to show to the user, and then the empty state. You want to just show that we don't have any results for this particular query. And then we want to show the pop-up again. We need to have a loading UI state. Now, if we started to migrate that, basically we need to obviously change and remove the callbacks lines. And Stateflow just have a setter that is set value, or in this case, value. And we're gonna make sure that we are passing the state with the loading UI state. So this will trigger this mechanism, and we'll see right now the pop-up we render that to the user. So then for the search tweet query, we'll make sure that we pass another state right there. We'll make sure that there is not empty results, but if there is, then we need to pass an empty UI state. That's all. But if we have any results, we'll pass the list results UI state with the tweets. And then we'll make sure that the value setter will pass this Stateflow. So this is going to be super quick, actually. Then we'll catch the different problems, and if we have any, we'll pass the error and we'll show up, and we handle that later into the UI. Obviously, it needs to be, again, with the launch in scope. This didn't change. But now, interestingly, we need to make sure that the Stateflow handler is making this collected. By that, I mean, we have the search tweet presenter with the use case, and this search tweet presenter gonna have embedded this use case, and this use case gonna be canceled, and we're gonna need to pass again the Stateflow from the use case to the other layers. But interestingly here, obviously we remove the callback. So we use the same methods we explained a moment ago, but we get rid of the different callbacks that we don't need anymore. And we'll expose these to the other collaborators. In this case, the view delegate. We'll expose that from the presenter to the view delegate, and then we'll initialize the processing query. For that, what I did here is passing the search view and the tweets list UI seal class, and I initialize this with the stateflow. As you can see here in the get stateflow is the one exposing this from the presenter. So this method is actually there into the tweets list UI. That's something like a fragment, a custom view, or an activity. Into there, I injected my view delegate and also my stateflow handler. So I initialize the stateflow handler with the stateflow plus the reference to the view that we're gonna use, and then we'll process this stateflow when it's required. This init stateflow, by the way, gonna be used from, let's say, on start. Stateflow handler actually gonna be in the activity scope, so we initialize that. We initialize the things as we are expecting. And into the stateflow handler, I will make sure that it's late in it because it should be initialized at the moment we have a stateflow, not earlier. Then, when we have this there, we need to collect it. So we're gonna do a filtering because we have a nullable state here. We will have every single use case we will need. We are not going to need actually a filter. So that's something that we can improve in the future. I'll do on each, and I will handle those states with the stateflow. I will make sure that the scope is there in the launch in, and yeah, with that we have this collected. But let's see what we have in handle states. So that's basically a stem function from tweets list UI. That's the view that we saw a moment ago, and we'll make sure that we are handling on states. So first of all, type save, and we're gonna show some loading when we have this first loading state, or we're gonna show some results when we have some tweets coming on, or we're gonna show an empty state if we don't have anything to tell to the user, or a problem, or if we want to have this by default with an empty state, we can do it, or we can show something else. Then in the stateflow handler, we'll cancel everything to make sure that we cancel and we make sure that static concurrency is working for us, and we'll make sure, because this is a helper of the view, that the null, the reference of the view is null, because we don't want to have memory leaks. Otherwise, we want to have it. And then from the view, we're gonna make sure that when we do launch on the story from the activity, this is launch, and we are canceling everything to make sure that there are no memory leaks. So that's all for the implementation. We're gonna have right now with this approach a full reactive with flow done, with all types of flow that we need for it. But let's see a few lessons learned along the way. For instance, exchangeable. What I mean by that is that we can reuse observables, singles, and in this case flows, and suspend functions, and change them as we want to. This library I mentioned is very useful because you can do the opposite way. You can actually change the approach, and instead of changing to coroutines, you can change from the other layers and coming from top to bottom. I did from bottom to top, but it can be changed. Also, static concurrency is super cool because we have a few advantages of this recursive cleanup, or we can have completable flows. That's an observable that is completed by itself, or yeah, a few advantages like that. Also, we have a pressure that I didn't mention, but you have also a pressure with flows. But the problem of static concurrency is that when it's gone, is gone actually when we are doing this migration. The problem is because we are passing observables from one layer. You are actually having here in the down layer those suspend functions. You return the type as an observable, but you want to have here static concurrency is not really possible because you change that to an observable, and this observable needs to have actually a life cycle that needs to be covered and needs to be handled properly. So yeah, that's the main problem I see here. And then imperative against declarative. Always I like to put this mem because I really like the fact that when you don't know how to work something like the naive approach I mentioned and all those kind of things, I try to do a declarative way, and then I realize that it's not the native way for them in coroutines. So for suspend functions, it's better to include them in an imperative way, and you don't need to overcomplicate with declarative way, but yeah, it's a bit confusing. When you are very used to RxJava and then you switch to coroutines, this is mind-blowing in my case. But yeah, maybe you do better than me. Then, just to summarize a little bit, there's few pros and cons that I saw is that basically RxJava is purely declarative. You're going to have a set of operations. You going to care more about what you want to do more than the how. That is the imperative way. Then coroutines and flow for suspend functions, you're going to do imperative. For flow, if you do emit, it's exactly the same. It's going to be imperative. But then if you're going to collect things, you're going to handle them, then this is going to be declarative. So you need to actually master both of them. RxJava does manual lifecycle handling. Unless you do any other library on the top of it, you use any other, then this can be done as well. Coroutines as flow with static concurrency is super cool. It has a few advantages that I really, really like. RxJava is good for hybrid projects, unless you have some crazy wildcards that it's not being covered, but maybe you need Rx Kotlin instead. And then if you don't need Java because you are super lucky, then you can just use coroutines as flows and friends. That's perfect. You don't need anything else. Then next steps, just to finish this bit. Waiting for stable flow APIs, but I think right now is everything or mostly everything is stable. Everything but the bonds, if I remember correctly, is not stable. And some APIs like this send channel so far. For the rest, Stateflow is actually stable. Also, Servflow is stable, and we have a few things that are coming on. So it's super good time for do that. So we're gonna avoid to have deprecated very soon, and you can be happy to go there. A special thanks to Manuel Vivo who helped me for the first and the second release of those slides. So thank you, Manuel. And thank you for attending today. Thank you for inviting me today to Kotlin London. If you have any questions, we'll see that later. But just very quickly, if you have any questions about anything that I explained today, I wrote a series of articles that you can read later on. So I'm going to share that later. You have this in the slides, so you can just download the slides and click one of those articles. I have a series of 7 of them. And yeah, if you have any questions, more than happy to answer now. Thank you.
See the questions. I just popped it into the...
Yes, it's a bit small. Thank
Is
you.
it better? Yeah.
I'm going to increase it even more, but I think it's okay, no worries. Yeah. Are you using Flow and Stateflow at Twitter? Okay, bear with me. I wish. We don't. I started actually this investigation and all my work last year to now, just to at least investigating and see a few advantages. This is actually something that I explore because we have a lot of legacy code that is into Java, and it's very difficult to migrate that with this amount of code that is combining Java and Kotlin, and also because we rely also in the different dispatchers that we use. Well, in this case, schedulers for more things than our servables. We use them also for libraries like Fresco. It's a bit like a bit of complicated, but yeah, we are in the way at least to think about it. Second question, in multi-module app architecture, where, okay, when I increase it a little bit the font because I cannot read it properly. In multi-module app architecture, where networking module is having RxJava and use everywhere in other modules, what migration strategy you will suggest? Okay. Let me read it myself again. In multi-module app architecture, where networking module is having RxJava and use everywhere in other modules, what migration strategy will you suggest? So basically what you are asking is the fact that you have RxJava and you are feeding the other modules with RxJava. So what I would suggest is basically if you need to use something with dispatchers, but well, dispatchers in this case flows, but you have still observables. The fact is that you can use this to observable if you need to change it, and then starting to migrate one thing with one another. So basically, in my opinion, you could start migrating things to suspend functions and then returning observables and singles. That's the approach I followed. But yeah, if you think anything else, obviously there are more ways than that. Okay, next question. Have you found any Rx bits hard to migrate to coroutines where the parallels are not so straightforward? Okay, I'm not very sure if I understand that, because where the parallels are not so straightforward, that means parallel like async, or that means anything else?
I think there's when some parallels between Rx and coroutine if you just switch between like a a function in Rx and function in coroutines, and when something is less obvious.
Well, in my opinion, the things that are very hard to migrate are probably the things that are a bit more different. So, for instance, channels is a big thing itself, and channels is complicated to understand, and I think everybody thinks in a similar way. Basically, that's why, for instance, conflated broadcast channels are gone, and on behalf of that, we have now Stateflow, which is a super focused and simple API, and Serflow, which is both of them are replacing broadcast channels. So channels is a way to communicate different coroutines, but I think is a very complete but difficult API. So for me, I think channels is probably the most complicated thing, because you need a big understanding of what is going on behind the scenes to have a good benefit of the usage of channels. So I will say that channels for me is more complicated than Flow, which is very straightforward, RxJava and Stateflow and so on. Thank you. And next question, Jorge. Based on your experience, what do you prefer, live data or Stateflow, and why? Okay, here let me be very honest. I don't have any experience with live data, and say that in other meetups and other talks I gave. But I know, because there are different articles I read, that actually Stateflow is equivalent to live data in the same functionalities. But if you are following the different conversations that there are going on in Twitter and Slacks, advantages that you don't have with the Stateflow that you have with live data. Live data, because it uses a few helpers with architecture components, uses launch when started or start. You can read that in my latest article about Stateflow, that it makes sure that you use it only when you have started on a start of in your application. Stateflow, the fact is that doesn't care about states. So sorry, it cares about the states, doesn't care about life cycle of Android, because Stateflow is meant to be used anywhere. You can use it in Android, you can use it in backend, you can use it in multi-platform. So that's basically it. You use Stateflow, you need to make sure that you are handling the life cycle of your application correctly. Otherwise, you're going to have crashes, unexpected crashes when you go to the background, because Stateflow also works in the background. So that's my tip of the day. Serving. What to do with use cases that need to be executed consecutively and have multiple scenarios to handle? They are hard to maintain, in my experience, hard to avoid. Okay, let me try to understand this, serving. What to do with use cases that need to be executed consecutively and have multiple scenarios to handle? Well, I don't know how you have your use cases, but use cases normally are supposed to be atomic, or at least have single responsibilities. That's why clean architecture is done in that way. If you need to do consecutively them, I suppose you need an orchestrator for them, because this is a more complicated scenario. So probably some way to do that is to use Stateflows as the return type, and then get into a place to synchronize them. But Stateflow is meant to be used for a single collector. So you need to have an orchestration of that. Probably Sharedflow is better because you are actually doing a broadcasting of those operations. And Sharedflow is precisely for that. It's a broadcast completed channel. So you need to handle those. You can return those types. And in another higher order, higher function use case, you can do that with a Sharedflow. I suppose that's the best approach, but they are hard to maintain in my experience. They are very hard to maintain. I agree. And how to avoid? Try to be and make things simple. Maybe there are things that can be made simple that they were already. I don't have a generic solution, but yeah, decomposing the problem and trying to make that simple, I suppose, is the best way to go. Sometimes it's not possible, but yeah, this is what it is. Next question also from Servin. Is the refactoring that you did today a recommendation for MVI as a state are already mapped to states? I suppose you can say yes from my experience, but architecture is something different to the purpose of this talk. That's why I didn't really care a lot about different architectures. I just relied in the one I had, which is MVP plus clean architecture. But because you use states, you can take advantage of that and then using MVI. But MVI is a bit more complicated than just states. If you truly gonna do MVI, you probably need a reducer. You're gonna need to make sure that you use unidirectional data flows, which is slightly more complicated, and you're gonna need to do some work behind the scenes that I didn't manage to do into here. So it really up to you how difficult you want to make that. But yeah, for sure, Stateflow helps to use MVI, for sure. Okay, I think that's all, unless there is any other questions coming on.